Recording is on.
Oh, Robert, you have some feedback loop there. But yeah, welcome to the third meeting of the Nixpkgs architecture team. Meeting notes are as always in the notepad there. I'm linking it in the channel as well again. Yeah, and so I'll do the recording today again. I'll upload it to Dropbox. I'm also going to take meeting notes today, unless somebody else volunteers to do it. Yeah, but starting off with just a bit of administration, member updates. Last time, after last week's meeting, John Erickson, someone that has done a lot of like STDN bootstrapping things in Nixpkgs and other Nix improvements, was interested in the team and to really help with some STDN cleanups. He said he would apply to the team, hasn't done that yet. Not sure if he's gonna join this week's meeting or if he'll be there afterwards. But yeah, I'm glad to have him also be interested in this. And with John last time, we had a meeting on Friday afterwards, where we talked a bit about STDNV and bootstrapping with him, where I really asked him a bunch of things about what STDNV is, how the bootstrapping happens in Nixpkgs. I learned that STDNV is kind of separate to bootstrapping. We made some meeting notes. These are also in the meetings repository uploaded there. Yeah, and so the question there is really like, is STDNV something worth kind of starting off with, or not STDNV, but bootstrapping? So like the initial premise was, we have Nix, we don't have Nixpkgs. How do we get from nothing to compiling a C package, for example? Turns out that's kind of difficult with like multiple stages necessary to do this. But I discussed with John whether it would be possible to kind of simplify this whole thing. The stages in STDN for the bootstrapping are kind of just like a fixed point, and multiple overrides are done in that. And it would be possible to move that into Nixpkgs, into the main Nixpkgs fixed point. But yeah, it's kind of, it's almost like a bit of a separate thing. The main insight I think I had there was that STDNV is just a collection of packages that's kind of used for the base of make derivation. And so if we have the discussion of redefining, like rebuilding make derivation from the ground up, we won't have a problem with that. We can just define and use our own package set. We don't need to, right? We can just make our own STDNV, or maybe a good idea is to not have an STDNV at all, to just say, if you have a dependency, you need to explicitly declare this all the time. There is no standard package set. There's no base package set. Yeah, that's mainly what I got out of it. Regarding that, does someone have something to say or something to add? All right. Yeah, there isn't many other things I've planned for this meeting, but David, just before this meeting, messaged me a prototype for a make derivation based on the module system. He didn't want to show it off, like, because it wasn't done yet, but maybe you can talk a bit about this.
Okay, so yeah, there's not a lot of implementation done yet, but I have written down the ideas behind it to be the main thing of concern right now. So yeah, the idea is to have to replace the standard end or have an alternative for it. So
David,
whatever.
Hold on. Could you like move closer to your microphone or something? It's super unclear.
Is it better now?
Yeah, thanks.
Wait a second. Maybe I can turn up the volume a bit. Hello, hello.
It's a bit overtuned now.
Okay. So like this, okay?
It's
intelligible to me.
Maybe like this.
Yeah,
is it better now?
We can hear you. Yes.
Okay. Yeah. So yeah, the idea is that this whole thing just depends on the Nixpkgs lib on the module system, and I bootstrapped some binaries myself, and everything starts with bootstrap binaries, so it doesn't have a dependency on any existing package expression of Nixpkgs. And yeah, one of the ideas is to have also like kind of an abstract concept of a build time. I'll call it build time interpreter. So right now this is usually bash, but you should be able to replace this with something else. And I did some experiments with Micropython because I thought maybe it's nicer than bash because it can handle data structures which come from Nix. And yeah, so that's one aspect. And another aspect, of course, is the bootstrapping. Should be easy to bootstrap. And I'm trying to not use any environment variables to pass information to builds. Instead, everything should just be JSON. So the build runtime, whatever it is, should be able to parse JSON and generate JSON, and also to communicate between build phases. JSON should be used as well. That's the idea. And yeah, everything is based on the module system. There shouldn't be any override functions anymore. And the granularity of a build should be flexible. So right now we have these build phases in Nixpkgs, and often I've seen the wish of some users in Discourse, for example, that they want to they want to have a build separated by the phases, so that different phases run in different derivations, and this is not.
You're cutting off there a bit. But so a question is: are the phases like a direct acyclic graph now, like DAG? So not like necessarily linear.
Right now it is the phases are just linear. Like yeah, it's just linear. So I mean, we could make it a DAG structure, I guess. But right now the idea is that phases are linear, but only between packages you can have these DAG-like dependency structures. But I'm not really sure about that, so that could be changed. But at least I thought it would be nice if the user wants, then all phases can be rendered into individual derivations, and otherwise it can also be built in one large derivation. So that should be up to the user. A phase kind of follows the same structure as a derivation. The input and produces output, and the output of one phase is fed as an input to the next phase.
Yeah,
and then we could add some other funny things on top, like for example, type checking whatever comes out of a phase with JSON schema or something like this. But that's just an idea.
Yeah, and so I guess the idea is that you'd combine all the phases into one derivation for like actually building a lot of things, but for debugging, you would then split them into individual derivations, so that you have a faster iteration.
Yeah, exactly. That was the thought behind it. Yeah, the copying between each phases, that's a good question. I don't think that will be necessary, because you can just set the out variable to some random new directory somewhere inside the sandbox, and then have another variable that gets passed into the next phase that is called, I don't know, out for the previous phase. So the next phase can always be the output of the previous phase. And I think it doesn't need to be copied around. It just stays there.
But
so most of our build phases involve modifying the current source root. So, and you wouldn't be able to do that if it was another store path.
Sorry, modifying what?
Most of our phases involve modifying the current the source root. So, for example, if you proceed from configure phase to build phase, if you've configured in one derivation, you're probably going to need to copy the result of that to do the build. And then install phase often ends up building a little bit as well. And so then you have to copy it again, unless the build system is separated in exactly the same way as our own phases.
Yeah, you're right. So maybe there's a little bit of a different approach that needs to be taken here.
Copying should be cheap too. Like, it's a lot of yak shaves, but you know, if you're using some sort of copy on write file system anyways, it's pretty embarrassing that ends up costing you know, a non-trivial effort on many cases with Unix. So yeah, I mean, it's hurting cats trying to fix that problem, but it will also take a while for new standoff to make its way through. So
yeah,
maybe copying isn't so bad after all. But yeah, I think
it depends.
Yeah. I mean, you will have to, like, just looking at the source directory, like each phase kind of will do its own thing to the build directory and maybe add files and stuff. I guess that also works with copy and write file systems, but it will. I feel like you'd get a lot of maybe not, like files aren't generally modified, just new files are being added over time.
But with current copy on write file systems, I'm thinking especially of ZFS here, a lot of our builds in many sensible setups are not getting the benefits of copy on write. So, for example, you might want your Nix directory to be snapshotted, and you might want your temp directory where the builds happen to not be snapshotted, which in ZFS requires making them different data sets. And that means that every build you're copying from the temp data set to the Nix data set and then getting no copy on write. So this has to be, actually this could be fixed in Nix if the build directory was moved into the Nix store so that it was guaranteed to be on the same file system, like if you had a Nix store temp. So we could do that, I suppose. But with the current way Nix works, copying is extremely expensive, and copy on write is has a lot of trade-offs if you want to take advantage of it.
Yeah, I mean, I totally agree. Out of the gate, it'll probably be slow and suck, but I sort of believe we should make our Nixpkgs infrastructure for the Nix we wish we had, and not the, you know, Nix today, Linux today, ZFS today, whatever. Because And I mean, it's hard to do that, but ultimately, like, these problems are fixable, and I think they can be fixed as a better layer. And that the right thing to do is have smaller derivations and figure out how to make smaller derivations not suck. So,
yeah, I wonder because there are might be a bit off topic for the team because we don't want to really develop Nix. We want to improve Nix packages with the current Nix we have, and I think there's a lot of potential there already.
yeah, no,
yeah,
like, as
it
long
could
as
also
this
go into
code-
that.
Sorry. I mean, I don't want to derail yet again with asking you all to be interested in fixing those things, but it's more like, I guess until it's a problem, people don't even know it realizes fixing. So until we're doing smaller derivations, these bottlenecks go undiscovered. We should just not like get into the weeds of fixing Nix, but we should just use Nix the way it ought to work. And as long as it's correct, that's good enough. And if slownesses are discovered, other people that want to do that, other people, maybe including me, should go fix that. But this team shouldn't try to hack around like other people not fixing these problems, because if everyone's hacking around everyone else not fixing the problems, we don't fix anything. Does that sound better?
Sounds reasonable to me.
Yes. So you're saying that if there is like a small problem in Nix or a small fix in Nix that we could do to improve Nix packages drastically, like the value to the cost value ratio is a lot, that we should just go for it and use that.
Well, I also mean like correctness versus performance. So as long as it's correct, you can do it right away and not be blocked. Because even a really small fix to Nix still is a huge impediment. Getting it merged, waiting for it to be deployed, waiting for it to be usable. But if it is corrected, even if it's slow as shit, do it anyways, and the performance can be fixed later.
Yeah. Alyssa?
Ash was first.
Oh, Ash, I didn't see who was first. Ash?
Yeah, I'm just concerned. So I think that if we're planning on doing this and ignoring the potential performance implications, like that affects not just like users as well or developers, it's also like Hydra. And we can't really like make that many times more expensive to run. So I think that if we're planning to do that, then we need some kind of concrete plan on how to address potential performance effects. Rust has their like whole performance regression tracking and stuff for that. Maybe we could do something similar, but we don't have like, if it's out of scope for this team, then we should probably figure out what team is responsible for that.
Yeah, Alyssa?
Yeah, that's similar to what I was going to say, but like, you know, even I think history is not really is sort of a counter argument here, because Nixpkgs eval is already extremely slow. If you're cross-compiling, it's even slower. And I have seen, I don't think that there's a lot of work that has been done in the last several years to try to optimize eval time in Nix. The only thing we've got is the eval cache in Flake, which is Flake specific and doesn't make eval faster. It just caches it if you're evaling exactly the same thing a second time. So I think that I think that if we don't care about performance, nobody else is going to. At least that hasn't been the case so far. So want to be convinced that that's somehow going to be different going forward.
Gittis maybe?
Yeah, about all these performance issues and splitting up the phases, may I recommend just considering all this out of scope? Because the way I see it, once we have something proper implemented, we should be able to refactor. And I'm not even sure if that's the correct approach of doing this. Ideally, it would be next feature, but like the second best feature would be to have something like Nix develop, which would execute all the phases and take snapshots on your host system, since it's meant for debugging anyways, and that shouldn't have any performance degradations. I mean, not the performance, but the whole splitting phases up, because it adds a lot of complexity, in my opinion.
So splitting phases should be out of scope, since it would be better implemented in Nix.
So as of right now, it adds a lot of complexity, but and there are, I think, better ways of dealing with such issue.
But I mean, phases right now are not at all. Oh, sorry, I'm just talking. I should raise my hand.
Yeah, I think John was next one.
Yeah, to Alyssa's point, I think just eval's more cursed and more complex. I think store layer stuff's just more salvageable, so that's why it would be different. But yeah, I mean, I see why the experience of the eval time also is not very inspiring, though. And to Git's point, I mean, I am also okay punting on that, but for complexity reasons or too much change too quick reasons. But just if we do want to do it and we do think we can get away with it, correctness wise, we shouldn't let performance get in our way.
Makes sense. Who was next?
I think it's me.
Yeah.
So I wanted to address Gitas's point about splitting phases being unnecessary. And I think that splitting phases is really necessary because, in fact, this is something that we already have to do in Nixpkgs. For example, we have the source-only function that tries to run a build that stops after the patch phase, so that you can get the sources that are used to build a particular package with patches applied and stuff. This is can be useful for just if you want to poke around the source tree. It's also critical for AGPL compliance. And so that's just, I don't know if maybe there are other examples as well, but there is a real need in Nixpkgs for at least some sort of phase splitting, and how was this thought going to finish? Yeah, I guess maybe that.
Yeah, so
sure.
I didn't say that it's unnecessary. I just think it's out of scope because it adds a lot of complexity, and I feel like there are better ways of dealing with such issue.
Out of scope for what?
For new builders infrastructure. I think once we have some sort of proof of concept already that's working, it shouldn't be difficult to implement even something like this. But as of right now, the way I see it, it's out of scope, and there are better ways to achieve this.
I think that's how sorry, I'm not really sure how this is interacting with the hand system, but I guess we should just finish this little tangent and then go back to the hand.
Sure.
I think that's how we've ended up with the current mess, because like source only is not a very nice implementation, and it relies on trying to manually disable all of the bits of standard end it doesn't want. And the whole reason it's such a mess is that standard end or make derivation in its current form wasn't designed with splitting phases in mind. And if we design a second system that also doesn't have phase splitting in mind, then I think we're going to we're going to end up in a very similar sort of situation. Robert says source only already works, and that's true. It does mostly work, but the implementation of it is not very not very nice, and it looks to me very fragile because it has to manually disable phases it doesn't want to use.
Yeah, maybe let's Dandelion and David. I think Dandelion was first. Go ahead.
Yeah. So regarding the splitting of phases again, like one option is to do the phase splitting, but I was thinking, is there another option to just go really deeper in and start using computed derivations? Either you could use it to split the phases, or you could use it for the deeper build tool derivations.
We definitely can use those, but I'm not sure that makes other things easier, because now, so everyone has to right now we can have setup hooks to make more phases, and you can imagine next level something to make more phases. But then if everyone needs to agree on a derivation, it's going to generate all the phases. That could be hard. I mean, I obviously like computed derivations a lot, but that feels to me more like the standard after the next one, or a parallel lane to next stream to next track. That's sort of very different spirit than trying to make our handwritten packages be better, if that makes sense.
Yeah, I wanted to add one more comment to the phase splitting, or the potential to not phase split and instead have better integration with the Nix tooling, so that Nix shell would better understand how to fast forward to a certain phase or something like this. I think it's just the problem is that there isn't really a concept of a phase, which is like a build time script that runs the hooks, and it can be modified during build time, and this is done in a lot of places. And I think, for me, as I was when I was starting out with Nix, I mean, the first hard thing to learn was the Nix language. But even when I was at a point where I could read the Nix code from Nixpkgs, it was really hard for me to grasp what is going to happen during a build if I start a build. And that's because the hook system, the way it's used, it's kind of messy, and it's hard to see what kind of steps are executed in a build before you start the build. And I think there's really need to reinvent that concept. I think that would be a very, very important thing, and totally in scope for this team.
We have a bunch of comments by Robert and John. Do you want to talk a bit about those? So Robert, for example, mentions, although that might be separate.
Yeah, I think we went on a bit of a tangent, but I think my two main things is that phases are inherently this imperative thing right now, and we can already work with it to some degree. And I think we'll probably want to have something like phases which are imperative, because that's kind of what you want to do in some cases. And the other thing is more of the tangents, which is discussion about Nix develop being architecturally suboptimal, because it's not actually the real sandbox, and the command itself makes assumptions about how Nixpkgs is implemented, which it shouldn't. But I think that's a separate discussion. Yeah. Tom?
I don't think I have much to add. You know more about the Docker checkpointing than I do, I would assume.
Let's let Tom speak.
Hi. Yeah. So, I what I don't know is what amount of splitting would just be there by default, but I think the ability to split is valuable. If for no other reason than to make it easy to split up things that are maybe too big. One problem I think that we've seen is that as if you're working on a derivation and you're trying to iterate on something, it's just painful if something is like a 2-hour thing and you're really only like modifying something in an install phase, right? So that sort of work, I think, is greatly benefited by having the ability to. And then there might even be situations where we purposefully say, not only do we have the ability to do it, but we actually do use that feature for the production version of the build. So it's not only for development purposes, but it's also for like, well, hey, this thing is just too unwieldy. So the actual build derivations are going to also take advantage of it. Now, once you have that ability, it also becomes perhaps very easily abused. And that, I think, might be some of the fear.
Yeah, Ashkit?
Yeah, so sorry, I don't know if somebody has suggested this yet, but have we considered using an overlay FS instead of copying? That might help with the performance.
I've experimented with Nix builds on overlay FS. The problem with overlay FS is that it works in subtly different ways to normal file systems, and that breaks builds. And in ways that are very confusing and not something that we can fix. So I think, and also not something that overlay FS can fix. It's a sort of fundamental limitation of it. So I think for things like Nixpkgs builds, where you're going to have stuff depending on every behavior of the file system, overlay FS is really feasible.
Yeah, something that was mentioned earlier by David originally, or I could ask him, was that the splitting of phases into derivations could only be used for like development, but in the end, it would be combined into a single derivation, which would then fix the most of the issues, I think, because it doesn't happen usually. And I think that assuming the combined derivation works the same as the split ones, which might be enforceable by more or less implementing kind of a Nix store within a kind of bash script inside the derivation builder that does the isolation properly, just as a Nix store would do. And that's way we can get.
I have done that, like not let's say in the fully featured way, but Nix, for example, has a feature where if you fetch many sources, you can pass a flag aggregate, and then it will do that. It just takes all the builder scripts of thousands of fixed output derivations and wraps them a little bit and makes sure that they are started in a new temp or temp dir is set to a new temporary directory and sets the out variable, and so it launches many builds within one build, and that seems to work fine as of now. But yeah, I've only tried that on simple derivations. Fetchers are quite simple.
Nice, yeah. So I guess we have two. I mean, so yeah, we've kind of had these two opinions. People arguing for splitting phases into multiple derivations, and people against. Do you think the split approach could kind of get rid of most of the concerns for either approach? Like, for example, Alyssa, do you think only having the last derivation in kind of the build tree be split, or kind of be able to dynamically say which derivations should be split and which not?
Yeah, I think as long as the splitting doesn't happen by default, then it's going to be totally fine. And I feel a bit bad for having kicked off this whole discussion about the split derivations and not having made that clear earlier. Like my question about whether it would require copying was just a question about, I'm interested in if you found a way to do it without copying, not this is a reason why it can't be done because of the. I don't think it could be done. I don't think we could have an output a derivation per phase by default, but as long as optional, that'd be totally fine. And in fact, I think having a more phase-aware approach to builds would be great, because we would get a better source only.
Nice, yeah. And right, I mean, even if we have such an abstraction which can dynamically choose between having multiple derivations or a single one, then right, that gives us a lot of benefit already. And with the CA derivations, that might also be super flexible, because you can just like change a derivation down the dependency tree to be built using multiple derivations, but then the end result is the same, which should lead to no rebuilds down the line, assuming it doesn't change. But yeah, either of those implementations, kind of the split one and the combined one, could be optimized individually, where right, the split one ideally doesn't do a lot of copying, and the combined one is, I don't know, faster and more efficient. I mean, that sounds pretty good.
I hope I'll find the time to experiment a bit more with this, since I'm already working on it, and maybe I have some more test results next week.
Yeah, then do we have any other points that people wanted to discuss? We talked a bit about phase splitting. I think we mostly talked about phase splitting here. Something about optimizing Nixpkgs and whether it should be in scope or not. I think John's mention of if we shouldn't let performance get in the way of a good design. I think that's a good point. We can later always kind of do more optimization, hopefully. There could be things designed in a way that are just inherently slow to do. I guess that could be something that happens. So we need to watch out a bit, I think. But otherwise, yeah, I'd like to have a good design from the start. And worry about performance later.
Oh, no one
Yeah,
else
Alyssa
is
mentions
talking,
it.
so I guess no one else is talking, so I guess I'll just say this with my voice rather in chat. I'm still very, very skeptical of worrying about performance later. Maybe, as John says, it's going to be okay for like store performance. I don't know. But eval performance has been such a problem for a long time that I'm very worried about making eval performance worse, because it sounds like there's not really much to be easily done about it from what John said. And the module system is particularly bad for eval performance. So I'm a bit worried about using that for all builds rather than just NixOS. So I would be, I'm obviously, this is just sort of my gut feeling about that it's going to make things worse. I'm open to being convinced with numbers and so on. But I think that if eval performance is so hard to improve, like John said, we can't be doing things that make us require significantly more eval, because it sounds like that's not really fixable. And yeah, the module system also has some other disadvantages, as John said. One thing that I don't really like about the module system is that it's very spooky action at a distance, where one module can
I think I get that.
vary how another one works. But that's
what kind of action?
kind of different. Spooky action at a distance is the term that I used.
Okay.
It's a sort of term of I think it comes from physics, and it's also used in computer science to refer to this sort of thing where like a spectre is a sort of spooky action at a distance.
You mean the fact that you can
John?
access every other option from any module anywhere?
Yeah, that is a common complaint about the module system. I agree. John wants to speak.
Oops, I might have been double muted. Yeah, it's a complete ambient authority problem, and that, like, not just confusing, but very hard to collaborate at a large scale when anything can affect anything else. So very much against not using, or against using the module system for not using it.
I have a question. Is there any issue if we have module system per particular package? So one derivation build equals one module system evaluation? Like it's can't interact outside of the scope? And that's at least what I'm doing, and I assume that's what David is doing.
So that already kind of happens a whole bunch in the module system. The submodules feature essentially is that, and during like normal NixOS evaluation, like thousands of submodule evaluations doing their kind of being limited to their own subset do happen, and so there isn't like a split on like a global level into this. Like you can't have top level option sets that can't write to each other, but within submodules you can kind of have that submodules can't write to their parents. It only goes downwards, not upwards.
One module system per package sounds more reasonable to me as well, as long as it isn't very, very slow, and I'm worried that it would be.
Yeah, the module system, due to its type checking and stuff, it is just slow.
Also, like I was thinking, but like module system can be actually improved upon. So like we can start using module system, but like it shouldn't be all that difficult to optimize it. I guess there could be some improvements done already, but also if we could get something like JSON validation merged in, or actually just integrate into Nix, that would be great.
I didn't quite get that JSON action or JSON.
I'll find the PR.
All right. Yeah, about optimizing the module system, I'm not sure. There have been some improvements in the past, but I feel like it's more or less stripped down to the essentials of what it needs to do. And I guess we could do more investigations into that, but fundamentally it does need to do type checking and merging and all of those things, which Nixpkgs, like the package evaluation, doesn't need to do right now. It just evaluates without type checking and stuff. Ash?
Yeah, I was also thinking that if we're talking about like abandoning setup hooks and considering some other way to do that, the NixOS module system has an issue where you can't really have like more than one instance of a module. And if we're talking about potentially having like support for an arbitrary number of build phases, you might want to repeat like have multiple invocations of a build phase potentially. So that might be an interesting thing to look at.
Yeah.
I'm trying to think of how to say this in a not too really way. I still think at some point we're gonna have to like really overhaul how eval time works for performance and all these other reasons. But I don't think that's, you know, means that what we do now is not important or just a stepping stone. It's so like if we basically get it so whatever the eval looks like, whatever other things look like, the final derivations we end up with are roughly what we want, which is not true today. That's hugely valuable. And it means that a totally different eval time could be a no hash just change non-mass rebuild or something closer to that. So just like a point of optimism. Yeah, for me, the most important thing is less like what the input looks like than getting that output to be better and sort of reflect trying to do less things in hacky ways, less bash, what have you. And then the other pieces can, after the fact, come together. Hope that
and so what by derivations, what you mean here? Do you mean the Nix evaluation derivations, like the out path, the DRV path, or do you also mean, I guess you also mean the store derivation?
Yeah, I mean the
although
store
that's more of a Nix level thing.
Yeah, the Nix level stuff.
Yeah, that sounds pretty good. So kind of get the derivation kind of layout and stuff figured out first, so we don't need to do a lot of rebuilds afterwards. Regarding that, what so we are kind of focusing on Nixpkgs, but like with the in-store derivation layout, that's not really in Nixpkgs power, I think, or do you mean, I guess do you mean the build derivations with like the output layout, like the bin folders, share folders, and so on?
Yeah, I don't mean changing Nix. Yeah, I mean like the result of evaluating Nixpkgs, which is you have a big plan, your derivation graph that uses a bunch of bash or whatever else. So just thinking not how that plan is executed, like the copying stuff we talked about, and not how that plan is created, but just that plan itself, the communication between the building part and the evaluation part. If we can get that the way we want with less bash, maybe something that looks like a setup hook, I'm pretty confident that the the previous steps. The evaluation things could be refactored well over time. This is similar to why I emphasize trying to like repackage the compilers. Just being able to have smaller scale builds, even if it's just today's ugly make derivation, unlocks so many things and makes a lot of other like nice stuff less daunting. So whether that or like splitting phases, whatever gets us divvying up the build time work in ways that make more sense, having sort of a more rational division of labor between derivations, really gets us so much flexibility.
Yeah. Let's see. Was there anything a point someone kind of we talked over in the past hour that someone still wants to have addressed or have replied to? All right, other things someone wants to mention or discuss. I guess we could also talk a bit about the the time is over in 5 minutes, so we don't have a lot of time left.
I think I just want to mention that issue number 3 about make derivation is still highly related.
So
that's the legacy make derivation issue.
Yeah, so the Nixpkgs architecture team issue number 3 there.
Yeah.
Right, yeah. Just linking it in here quickly.
Yeah, it has a lot of surface area with the things we've been discussing. And they're generally less ambitious. So they might be good starting points and definitely things to keep in mind.
Yes, right, and actually the David's kind of module system exploration of this, yeah, he mentions in it that he kind of used this issue for some of the inspiration and kind of like, for example, the environment passing. Yeah.
Can I just note that I implemented more or less the same thing, but like it's more complete at this point? So like maybe you could take some points from that, or just like copy the module since it's a lot of writing.
Where did you implement this?
I'll have a look at that.
The reinventing the wheel repository. It's been quite a while ago, actually. It's not complete.
Second post in the chat here.
Yeah, I posted it. Like as of right now, it can build something. Of course, there is no cross-compilation support, no bootstrapping, but hey, it has phases, it builds, it has modules. It passes JSON directly to the builder instead of using environment variables. What else? I like the phases because each phase has its own index, so you can have infinite amount of them without manually tweaking like phases array. So this allows us to create like smaller phases, which should in turn result in us being easier. It should result in us being easier to override those, because sometimes it's quite a pain. Not sure what else should I share about this. Any questions?
No, but that looks very interesting. I'm gonna take a look at that. Right, and that, yeah, I think how we should proceed here is to really, well, ideally write a small document kind of comparing the approaches, describing them, benefits, advantages, advantages, disadvantages? Maybe we can take some ideas from those.
I think the ideas are very similar. Like, doesn't differ too much. Actually, still wasn't quite clear on module system of David. How is it being evaluated?
Yeah, we could also maybe next time really take a deeper dive at these approaches and look at them individually. Maybe measure. Well, maybe just look at the interface to like go over each point. What do we like about each of these designs? Maybe try to find some more, or maybe improve them as we see them.
Yeah,
I think that would be a good idea. I think, I'd have a bit more time to experiment until next time. And yeah, Peter's, your project is really interesting and very similar in many points. And I'll definitely have a look at that.
Also, like about the Micropython, it depends on Python 3 itself, the bootstraps. So that's going to be a pain. And
that's
also,
just for the test. It's just
all right,
test.
if it's for testing,
it really depends on Python 3.
Another like just concern I have with like Python stuff, it's like indentation based, and we are just concatenating strings, so that could end up dirty.
I think right now every phase needs to be one Python file. That solves the problem, right?
In Python, you can access the scope first class, so you can actually do like hygienic code copy and paste, so to speak.
You can do what?
So instead of concatenation, you can have evaluation of Python code that accesses the scope. So it's actually quite flexible. And
like bytecode?
Yeah.
Okay, that's cool actually.
I'm not actually sure about Python 3, but probably they kept that.
All right.
Yeah. All right, but yeah, we are out of time. Thanks all for participating. I'll upload the meeting notes. I don't see who's talking.
Sorry, that was me. I just wanted to mention that the Micropython thing is also just an experiment. The idea of the abstraction is that there can be different build runtimes. Micropython would just be one example. So as long as it can parse JSON and produce JSON and all these kinds of things, then it should be fine.
All right.
All right, cool. Feel also free to, I'll upload meeting notes only a bit later, so feel free to kind of expand them a bit if you'd like to mention something or expand on some points. All right, but otherwise, thanks all for participating, and let's continue with this next week. See you all around.
Bye.
Bye.
See you.